This tutorial, we're going to use the load analysis pipeline to synthesize loads for a GridLabD model. So we again add the load analysis pipeline from the GitHub repository. And we start a run. And in this case, we're going to do the same thing we did before when we did the load analysis. But this time we're going to also load a load map file that will allow us to establish the correspondence between the meter data that is present in the AMI file and a load model in a GridLabD simulation. So let's first load the AMI data. Again, the time zone header is not the same as the default in this case, so we just need to fix the time zone column. And now here, instead of removing the GLM file outputs that are present by default, we're now going to provide this load map that will allow us to establish the correspondence between the two. The load map file itself simply contains information that's required for the to establish the correspondence between the meter data and load objects in the network model itself. So we're going to upload this file. If you want additional information about this load mapping, you can go to the help page, and there is additional information about this optional input and how this information is, what is required for this to work. You do not have to use simply power fractions. You can also use current and impedance fractions. If you're also loading triplex loads instead of load objects, you can use, instead of the ABC phase information, you can use the line information, line 1, line 2, or line 1, 2 for the 220 volt components of the loads. So once you've provided all this information, you can submit the form, and the run is ready to begin. Okay, so the run is completed. And as before, we have the groups information that is giving us the mapping of the loads to the meter loads data to specific groups that have been identified in the load shape analysis. But we also have the plot of the load shapes as before, as well as the load shape data. But you can see we now have a number of GLM files that are available for use in a GridLabD simulation. The clock GLM file contains the information about the time span over which the AMI data was collected so that it can be used as part of a simulation, since the earliest meter record and the last meter record really define the time span for which this AMI data is valid. You can use this then to start and stop simulation at those particular times. The load data itself contains the specific loads. And so you can see each load object is attached to a load bus on the network model and the power flow with the information that was provided in the load map file. And each load is then scaled from the load shape that was generated by the load analysis, which as you can see, each one is slightly different. This allows the load shape to have the correct energy consumption, basically scaling each load shape so that it matches the original AMI data. The load shapes themselves are defined in the load shape GLM file, and they're essentially defined as schedules where each season, day type, and hour corresponding to the data that's in the load shape CSV file is provided. And this is, of course, for each of the load shapes that were given in the group, the grouping that was provided in the configuration file. So in this case, there should be 4 load shapes, each one having a season, a day type, and an hour of day entry. So that's it for this tutorial. That information is really all you need to generate a GridLabD model that corresponds to the load shape data in AMI. Thank you for watching.